Hey there YouTube, this is SGM4306 back with another video, and today happens to be Christmas, so, happy holidays, Merry Christmas, all that jazz. So yeah, I just wanted to put out a quick video, something that I've did a little more work on. If you guys remember this little adapter that I made for my NES and SNES Classic consoles that allows me to use this custom-made wireless SNES controller that I made, I actually amended this a bit. I took the same Bluetooth module, and I took an Arduino Leonardo, which is just an ATmega32U4, and I reprogrammed this to act as a USB keyboard. So now, if I use this wireless controller, I can use this with Steam or any PC emulator or game, basically, because it just emulates a keyboard. So I did a little bit of fancy programming though, and let me show you exactly what's going on. Okay, so hopefully you guys can see this is the software that I wrote, and I'm using the keyboard library as well as the E2PROM library to save values to internal memory. So I basically have every single key. It has a portion in the EEPROM memory that when it first boots up, it loads into to RAM. And so this way I can actually reprogram on the fly, and it'll remember what key you bound to what button, basically. And so I have some software that'll take a serial input, it'll tokenize it so that it can extract what command and what argument you're sending it through the serial terminal. And I have some definitions for these key macros for like modifiers like left shift, right shift, the function keys F1, F2, etc., etc. And I have everything defined so that it can store and extract that information from EEPROM so you can program it. So here I'm actually using two serial ports. It's actually rather interesting. I'm using serial 1 is the Bluetooth port, basically, and then serial is your USB serial port, basically. So I have to run these kind of simultaneously, but I actually have to disable the keyboard functionality when I'm writing or reading from the serial port, otherwise the USB serial port, otherwise it won't work. So anyway, basic functionality is at the beginning of my loop, I check to see if any characters in the receive USB character buffer has gotten anything, and then if that is true, I set a flag so I can enter here in order to tell you, how to program the keyboard over the serial COM port and whatnot. Other than that, I basically go through and I'm looking for specific keywords like up, down, left, right, etc., etc. And if it receives those and a space and then another character afterwards, it'll take that character, for instance B, and it'll program into the memory location for B, whatever that character that you typed was, whatever that keystroke. And it does all this, and it prints out OK if it programmed correctly. If it receives an improper program, improper command, it'll give me an error, and you can exit out of the programming, and etc., etc. And once that's all done, it goes into this portion here, reads the packet from the Bluetooth, and it extracts the different bits for all the button states. And it stores them so that later on here, it can determine whether it should press the button or release the button. And that's literally all the program does. And at the very end, this just toggles the LED, the onboard LED. If any buttons were pressed, it'll turn it on, else it turns it off. So that's literally all my program does. So we can just go up here and flash it. Okay, and we're done programming. So I'm just going to go ahead and plug these wires in now. Now, one thing to know is this Bluetooth module, kind of hard to see, sorry about that, is unfortunately it's 3.3 volts. There is an onboard regulator, but the signaling should still be constrained to 3.3 volts for the ARCs and TX lines. I'm ignoring that momentarily, which isn't a very smart thing to do, admittedly, but for testing it for a couple seconds, it'll be fine. So we got ground, we got VCC, and then we have RX. So it's all plugged in, it's blinking away, waiting for a command from the controller, which I shall turn on now. And once this purple goes away, it will be fully mapped. Well, fully synced. There we go. And it looks like my battery is in between green and blue. But anyway, we're connected here. You can see it says, Bluetooth receiver config version 1.0. My username, and then it has what commands you can enter to keybind. So up, down, left, right, A, B, X, Y, start, select, and shoulder left, shoulder right, followed by the key to map. And for a list of available modifiers, type help. So if I type help here, it will spit out pretty much everything, all the available commands, as well as all the available modifiers. If I type list, what it does is it prints out what the current configuration is. So you can see up is the key up arrow, and then followed by the hexadecimal value. I use this to debug. It's not necessary to know that key up arrow equals 0xDA, but for debugging this was helpful. So I just kind of left that in there. And for standard characters, it spits out the equivalent ASCII value. So, for instance, A is 0x61, 61 hex basically. So if I wanted to program a key, so I could say A, it has to be capital, and then followed by, say I want to program that to Y. If I hit enter, you can see at the bottom here it says OK, 0x79 hex. Y. So now if I type list, then A will be Y. So here you can see it successfully changed. I'm just going to change that back since I don't want A to be Y. I want A to be A. And there we go. So it's back to being A. So if I were to open up Notepad, doesn't matter, just a regular Notepad, the controller is synced. So you can see I can actually type using this wireless controller, and I can go left and right as well with the cursor. That might be kind of hard to see, but anyway, yeah, everything works. You can see here I'd set this to enter and delete, or backspace rather. So start and select, do that. So yeah, everything works. And this is fully usable now within any game, basically. Yeah, that battery life is like right on the limit. It keeps flashing between green and blue. But anyway, yeah. So it definitely is fully possible to use, the same exact components, other than this processor now is USB capable. The processor I was using for the NES Classic dongle, this is a ATmega 328P. So this is basically the same chip in the Arduino Uno, basically. And this does not have native USB capability in hardware. The ATmega 32U4 does, however, so this can emulate a USB keyboard and mouse, which is freaking awesome. So I actually have a few plans in addition to this that I'm thinking of doing, but that'll be at a future date. Anyway, I've rambled on for about 10 minutes, it seems, and I just wanted to give you guys a quick demo of the new functionality, the new software, basically being able to reprogram on the fly any key to any button on this controller, which is pretty cool. I haven't really checked the latency, but I'm assuming it's going to be kind of on par with this guy, so maybe a couple frames at 60 hertz that are lost due to latency. But anyway, hopefully you guys enjoyed the video, and yeah, I'll be releasing this on the hackaday.io page, the firmware for this and all. So if you guys want to play around with this, make your own wireless game controllers or keyboards, you're welcome to use my software. Anyway, I'll see you guys in the next one, and oh yeah, happy holidays.